Hello everyone, my name is Yifan Zhang and I will talk about the problem 2 in homework 2. This problem is similar to with the previous video in homework 1 and it's also about the noise system, but it's more complicated because it has several levels of this noise channel, and we can say that the noise will cause the signal from 0 to 1 or from 1 to 0. So let's talk about the probability. So that from 0 to 0 is 0 0.6, and from 0 to 1 it's 1 minus 0 0.6, so it's 0 0.4. The from 1 to 0 is 0 0.3, and from 1 to 1 is 0 0.7. So the probability that the 0 is sent out is 0 0.2, and the probability of 1 is sent out is 0 0.6, 0 0.8, and that is the problem. So let's talk about the first question, that x equal to 1. So it means that the 1, this is received. So sorry, it means that this is received. So there are only two methods to accomplish it. So it means that it means that 0 is sent out and it was transferred to 1 by the noise, or the 1 is sent out and it was transmitted correctly. So the probability is that like the probability of this from 0 to 1 and is 0 0.4, and the probability that 0 is sent out is 0 0.2, and the probability that 1 to 1 is 0 0.7, and 1 is sent out is 0 0.8. So the result is 0 0.64. This is the first question. When we talk about the second question, that to find the probability that x3 equals 1, it means that we need to get this. So we have to find that we have no x1 equals x2 equals 1 equals 0 0.64. So x2 equals 0 is 1 minus x2 equals 1. It's that 0 0.36. So when we need the probability that x3 equals 1, is also similar to the previous one. When x3 equals 1 and x2 equals 0, it means that from the signal from 0 to 1, and multiply the probability that 0 is sent out, and this is that from 1 to 1, and the probability that 1 is sent out. So it's all similar to the previous. So it's 0 0.4 multiply the probability in this, and it's 0 0.7 multiply the probability in this. So it's 0 0.592, and that's a result of question 2. And question 3 is that when x3 equals 1, find the probability that x1 equals 0. So we can transfer it to the probability that x1 equals 0 and x3 equals 1. So divide x3 equals 1, and this is shown in the previous is 0 0.592, and the upper one is that find the probability of x3 equals 1 when x1 equals 0, multiply x1 equals 0's probability. So it means that when 0 is sent out, we need to find the probability of x1 is received. So we have make sure that 0 is sent out. So it has only two situations, from 0 to 0 and to 1, and from 0 to 1 and to 1. And this is 0.6. Multiply this, so 0.4, and plus this 0.6. Multiply this from 1 to 1, so it's 0.7, and this is upper. So this is upper one, multiply 0. So the probability that 0 is sent out, so it's 0.2, and divide the previous result. So the result is 0.176. And the fourth question is that we need to find when n tends to be infinity, the probability that xn equals 0. So to find this situation, we need to find the regulation. So we need to find the connection between the separate dot. So I mean that we need to find xn equals 1 probability, and this previous xn minus 1 equals 0. So their connection. So we can see that xn equals 0, probability equals xn minus 1 equals 0, multiply 0.6 is that net from 0 to 0, and xn minus 1 equals 1, multiply 0.4 is like that. So 1 multiply 1 to 0, and the probability is that, it's like that. So it's 1 to 0, so the probability is 0.3. So we can see that this equation is correct because this is 1 minus this. So we have this equation, and we can find the transformation that xn equals 0's probability minus 3 divided 7 equals 0.3, multiply xn minus 1 equals 0's probability minus 3 divided 7, and we can transfer it to this. So xn equals 0's probability equals minus 8 divided 35 minus 0.3 power minus 1 plus 7 divided 3 divided 7. And when n tends to be infinity, this will become 0, and the final result is 3 divided 7. And that is the result. Thank you.